Now that we've showed you how to adjust for imperfect detectability by measuring distances to objects in line transects, we want you to do some calculations. We want you to work with some data from duck nests that I'm showing you here in this table. What you'll be asked to do is you'll be asked to make a histogram, such as the ones you've seen in the previous lecture, from the data that are displayed in this table. The purpose of all of this is to try to estimate the density of duck nests from this study. What we know, or what you're provided with, is overall there are 534 nests detected, given that the observers had walked over 2,500 kilometers of transects. The measurements were taken of duck nests seen within 2.4 meters of the transect line. So we've provided you with 8 distance bands and the number of nests seen in those bands. The first band, out to 0.3 meters from the transect, there were 74 nests detected. In the next band of width 0.3 meters, there were 73 nests detected, etc. Your job is to take a piece of graph paper and make a histogram out of those 8 values. Once you've made a histogram from those 8 values, you are to fit a detection function to those data. The way in which you do that is up to you, and we'll talk about ways of doing that after you've had a chance to try it. Having placed a detection function through this histogram of data, your next steps, as you read through this exercise, your next steps will be to calculate the area under that curve that you've passed through those histogram bars, and calculate the area of the rectangle, such as the one we described in the lecture. Once you've done those 2 things, you'll be able to, as we've shown you here, calculate P sub A as the area under that curve divided by the area under that rectangle. The next step in the calculation of duck nest density is to use that P sub A to produce a number of nests in the area covered by the survey. You can then transform that abundance of duck nests into a density of duck nests. And that's what we want you to calculate now. Good luck.